So imagine a machine that can, effortlessly pass the bar exam in the morning and then draft this totally flawless legal contract over lunch.
But then it completely fails to figure out how to stack two wooden blocks in the afternoon.
Right, exactly. That is the totally bizarre, paradoxical reality of artificial intelligence today.
Yeah.
We are living in this weird moment where machines seem simultaneously omniscient, but also just entirely oblivious.
Yeah, they really do. But we are rapidly approaching this threshold where those limitations might just, vanish entirely.
Which is why you hear about AI everywhere right now. Decades ago, Alan Turing asked this very straightforward question, can machines think? And for a long time, that was just like a late-night thought experiment.
Right, but now it is arguably the most urgent engineering challenge on the planet. We're standing on the edge of a massive transition.
And to figure out where this is all actually heading, we're doing a deep dive today into a really fascinating document titled AI TrueCast 10, What Comes Next. Docs.
Be a great source.
It really is. Our mission today is to unpack the reality of artificial general intelligence, or AGI, and look at the fierce, almost Civil War level debates happening among the world's top experts about when, or even if, it will arrive.
Yeah, and we're also going to examine how governments are frantically trying to regulate a technology that is just evolving way faster than we can comprehend.
Exactly, because this answer to Turing's question, it might forever change the trajectory of human history. But before we can talk about the future, we have to establish what the actual finish line of AI development looks like.
Right, because it's wildly different from the AI you use today. Even the most impressive tools we have right now are fundamentally what we call narrow.
Break that down for us. What does narrow mean in this context?
So narrow AI is astonishingly capable, but it's locked inside a very specific box. Like you can train a model to absolutely obliterate the human grandmaster at chess.
Oh, sure. It'll calculate millions of moves a second and win flawlessly.
Exactly. But if you take that exact same model and ask it to play a game of checkers, or, explain why it won, it fails completely. It has no generalized capability. It's just hyper-specialized optimization.
So AGI is basically breaking out of that box.
Yes, AGI implies artificial general intelligence. We're talking about a hypothetical system that permanently and irreversibly surpasses human intelligence across all domains, not just math or coding.
Like emotional nuance, social dynamics.
Physical reasoning, creative synthesis, all of it. Human intelligence is this incredibly messy, intertwined web of capabilities. A true AGI would be able to do everything a human can do in any context and transfer that knowledge seamlessly.
But I'm looking at the source and looking at the capabilities of the models we currently have. The lines are already getting incredibly blurry, aren't they?
Oh, absolutely.
Because we have systems like GPT-4 scoring in the top percentiles on medical licensing exams, writing really useful code, reasoning through complex logic puzzles. I mean, it's kind of like a highly specialized savant.
That's a really good analogy, actually.
Right. Like brilliant at taking a medical exam, but completely helpless in the real world. Which brings up a major philosophical pushback from the text. If a machine produces the exact same flawless medical diagnosis as a human doctor, is it actually reasoning?
Or is it just the illusion of intelligence?
Exactly. Is it just incredibly sophisticated pattern matching?
That right there is the core divide in the field. To answer that, you have to look at how these current systems actually function. Most of the breakthroughs we are seeing are driven by this thing called a transformer architecture.
Okay, transformer.
At its most basic structural level, a transformer model is a prediction engine. You feed it massive amounts of text, essentially the entire public internet, and it just learns the statistical probability of which word or token should logically follow the previous one.
So it really is just autocorrect on steroids.
Basically, yeah.
It doesn't actually know what a contract is or where medicine is. It just maps out this giant, multidimensional web of how words relate to each other.
Yes, but it is a statistical web so impossibly vast and complex that it begins to mimic reasoning. And the debate is over whether mimicking reasoning at a high enough scale eventually just becomes reasoning.
Because nobody actually knows when AGI will arrive, right? The timeline debate is all over the place.
It really is. The history of AI predictions is famously wrong in both directions. You have Sam Altman suggesting AGI could be here in just a few years.
Which is terrifyingly soon.
Right, but others say decades. And some argue that current transformer-based models are structurally incapable of ever replicating human intelligence.
Well, let's talk about what happens if we do cross that threshold, because the source warns that the growth won't just stop at human-level intelligence, right? It could accelerate unimaginably fast.
This is where we get into the concepts of
It
superintelligence.
sounds like a sci-fi movie.
It really does. But superintelligence is a system that surpasses human intelligence not by a little, but by an enormous margin. The philosopher Nick Bostrom and the Machine Intelligence Research Institute, or MIRI, they outline this concept of recursive self-improvement.
Okay, walk me through how that actually works.
Imagine an AGI that has reached the level of a senior human AI researcher. It understands its own underlying code, its architecture, everything. Because it's a machine, it operates at the speed of computation.
Not biological thought, right?
Exactly. So it can work on its own code 24 hours a day,
Hmm.
running millions of simulated tests in seconds. It finds inefficiencies, rewrites them, and boom,
So it just pushes a software update to itself.
basically. But that slightly improved version is now even smarter, which allows it to make further improvements. The cycle continues, and it improves, which makes it better at improving.
I have to push back on this a bit, though. This terrifying intelligence explosion, isn't there a logical limit to how smart something can get?
When you,
Like, just as there's a speed limit to light, right? A software program can't just invent more microchips out of thin air. It needs energy. Why is an uncontrollable exponential explosion just taken as a given by some of these researchers?
that's a fair question, and physical constraints absolutely exist. But here's why the stakes of this recursive loop are taken so seriously. If it happens, even if it hits a physical ceiling, that ceiling might be 10 or 20 times higher than human cognitive capability.
Oh, wow.
Right. Humans would be left far behind, rapidly and uncontrollably. If a superintelligent system decides on a goal that misaligns with human survival, we wouldn't even have the time to recognize the threat.
Because it's operating millions of times faster than us.
Exactly. Which is why the smartest people in the world, even the foundational pioneers of AI, are fiercely divided on how to handle it.
It's literally a great divide. You've got the doomers on one side and the skeptics on the other.
Let's start with the cautious camp. You have researchers like Jeffrey Hinton and Yoshua Bengio. These are the guys who built the deep learning frameworks we use today.
And they take the superintelligence threat very seriously.
Very seriously. Their stance is that the consequences of getting this wrong are so severe, so irreversible, that even a tiny probability of catastrophe like a 1% chance justifies massive caution and investment in AI safety.
But then you contrast that with Jan LeCun and the other skeptics.
Right, LeCun argues that the path to superintelligence is highly uncertain and far longer than the doomers believe.
Because current systems lack basic common sense.
Exactly.
Huh?
A toddler understands physics intuitively. If a glass falls, a kid knows it shatters. A transformer model only knows that the text string glass falls is statistically correlated with shatters. It doesn't have a physical model of the real world.
Right. I want to zero in on a specific, powerful quote from the skeptics in the text. They call the intelligence explosion science fiction masquerading as extrapolation.
It's a great line.
It is. But as a listener, how are you supposed to navigate a landscape where the literal architects of the technology completely contradict each other? It's tough. Both sides make valid points, honestly. The skeptics are right about the structural limitations of current architectures. You probably can't just scale up a text predictor and get a godlike intelligence.
Right?
But the cautious camp is right about the asymmetrical risks. The consequences of being wrong about superintelligence are just too high to ignore.
Which is wild to think about. But while the philosophers and pioneers debate the distant future, the immediate, near-term reality is happening right now.
Yeah,
And it's already world-altering.
it really is. The capabilities are moving rapidly from research to actual products. We're seeing multimodal AI now.
Meaning systems that can see, hear, speak, and act all at once.
Yes. We are moving into the era of autonomous agents. These aren't just chatbots where you type a prompt and wait. These are agents that can browse the web, write and execute code, and complete multi-step tasks with minimal supervision.
And the text also notes rapid improvements in integrating AI into robotics, right? For physical tasks in unstructured environments. Yeah, that's huge. Historically, robots needed perfectly structured factory floors. Now, with advanced spatial AI, a robot can navigate a messy, changing environment like a warehouse or a kitchen and reason its way through obstacles in real time.
Which means, for you listening to this, over the next few years, you are going to see this embedded into virtually every digital product and service you use. You really don't have to wait for AGI to feel the massive economic and social consequences of these tools.
No, you don't. And with autonomous agents and multimodal AI deploying at breakneck speed, the obvious question is who is driving the bus here? What are the rules?
The governance scramble.
Exactly. The regulatory lag is massive right now. AI is moving much faster than any legislative framework possibly can.
Well, the source mentions three main global approaches to this. Let's break them down. First up, the EU,
So the EU passed the AI Act in 2024.
which was the world's first comprehensive regulation, wasn't it?
It was. They're using a risk-based tier system. They outright banned certain high-risk applications, like biometric mass surveillance, and for other high-risk stuff, they require massive transparency and rigorous testing.
Okay, so that's the EU. But the US is taking a completely different route.
Yeah, the U.S. has a much lighter touch approach. They're relying heavily on voluntary commitments from companies and some executive orders. It's fundamentally innovation-focused. They don't want to slow down and lose the geopolitical edge.
And then there's China.
China is implementing regulations focused specifically on algorithmic recommendation systems and generative AI. Their primary concern is ensuring the outputs align with state guidelines. It's regulation designed for information control.
So comparing this global regulatory effort, it feels a bit like trying to write traffic laws while the cars are inventing themselves and changing their top speeds every single day.
That is the perfect way to put it. And the core governance flaw, the most urgent warning from the source, is that none of these current frameworks were actually designed for AGI.
Right, they only manage the AI of today.
Exactly. They regulate chatbots and deepfakes. The central challenge of our time is building global, adaptable frameworks that represent the interests of everyday people who aren't in the rooms where these decisions are being made.
Because it affects all of us. So just to wrap up this journey today, we've summarized the leap from narrow AI passing the bar exam all the way to this fierce debate over superintelligence and recursive self-improvement.
And down to the urgent need for global governance of autonomous agents.
Yeah. But I want to reiterate a key point from the source because it's empowering. The future of AI is not predetermined.
It absolutely is not. We are only at the beginning of a rapidly written chapter. It is being built right now by specific people making specific choices.
And you, the listener, have a massive stake in how those choices turn out. The best thing you can do is just pay attention and ask hard questions. But I do want to leave you with a final, lingering thought to ponder today. Building on those warnings about governance, we know our current laws are only designed for today's AI. But if a system truly reaches superintelligence and begins recursively improving its own design at lightning speed, would any human-made law or software constraint even be comprehensible to it?
That is the question, isn't it?
Right. Or would our global regulations just look like a colony of ants trying to write a treaty to stop a bulldozer? Definitely something